So the chapter that we started in the last lecture, it's about machine code. So I already uploaded a file. Thank you. I already uploaded a file in a Blackboard. It's about machine code rules or machine code template, something like that. So keep that file with, in front of you, or keep that file open so that you can follow me. It will be easier for you to understand. Okay, let's see another example. So last class, in the last class we discussed about so it's looking for bit slow. Okay, I hope it will be normal soon. Yeah, can you hear me? Yeah, is it okay? Can you hear me? Okay, okay, thank you. So, last class we discussed an example. An example, it's move BL, AL. Okay, so now let us have a look. Like add AX, square bracket SI. So that means square bracket means memory location, right? So the content of AX, adding the content of AX with the memory location data. So memory location data, that the offset of the memory location is represented by SI, right? So that means so 16 bit. So SI memory location, that means two memory location. So first one offset address is represented by SI because AX. So AX comma square bracket SI. So memory data. So memory data, the offset address of the memory location represented by SI, that will be memory data will be added up with AX. Okay, so what is the format for this one? Let us have a look. So we know that this is the so this is for the first byte, second byte, and this is for the first byte. Okay, and until here it is opcode. Sorry, we write it down, opcode. Okay, here opcode, code, and then we have D, and then we have W, right? Okay, and now here we have three field. One is for mod, okay, and one is for REG, and one is for register or memory. Register or memory. All right. So now the opcode. So for this instruction, what is the opcode? Opcode is, for example, is given 6 zeros, 0 0 0 0 0 0 6 0. Okay, and now the direction. So look at here the direction. So we say that to resistor it is 1, and from resistor it is 0. So to resistor, because you can see we have the result will be saved. I mean, first operand is the resistor, right? And second operand is the memory location. So memory location, but it indirectly represented by the another resistor. Okay, so first memory look, so it is the operand is a resistor, and this is the destination operand. So it's the two resistor, right? So two resistor, definitely what it will be? It will be 1. And what is W? Is it a 16-bit operation or 8-bit operation? 16-bit. So W is 1. Yes. Okay. Very good. All right. All right. So now first byte is done. First byte is done. What about the second byte? Second byte, I say that mod, mod, it is memory of. So if it is a memory related operation, it can be 0001, 3 different types of memory operation. Memory mode 0001 and 10, and if there is no memory involved in in our operation, there is no memory, neither operand is memory, then it is a resistor mode. So here actually it is a memory mode, right? Because yeah, yeah, it is a memory mode. Mode is the memory mode with no offset displacement. Yes, you are right. So that means it is 00. So it is 00. First one, memory mode, but without displacement. So it is 00. And then we know that this mode is related with register oblique memory. This one is fully related with the mode. So now look at here. What will be the mode? Okay, let me open the I forgot to open the file also. Let me open the PDF file. The file related to the rules. Then it will be easy for me to say. Okay. Machine code. Template. Okay, so now if you look at the file, so 00 for 00 mode, what will be the register oblique memory for register oblique memory? Okay, first of all, here which one is, so register is for AX, right? REG for AX. But what about the register oblique? So definitely register oblique memory is related to the memory. Offset address is indicated by SI. So let us have a look in the table. If you look at the table, you can see for mode 00, for mode 00, the if the yeah, you can see is the memory location represented by SI. Register oblique memory is 100. Register oblique memory is 100. Can you see it? 100. Yeah, you can follow it. Yes. No. Okay. So look at here again. Yeah. So yeah, there is a table. if you look at the table, that mode 00, look at the mode 00. Under the mode 00, the memory location represented by the SI. You can see the bracket, within a bracket SI. Then R oblique M, register or memory is 100. Okay, so let me finish this one, then I will back the file. Okay, because otherwise if I back, then it will be everything will be I mean erased, so I will not get it again. And then now, so everything is done except the AX, except the REG field. So REG field for AX, and you can, I mean, you can use the table for REG. You can use the table for REG, or you can see. Okay, better to say, make it easy. Where is the REG field? At the down. I mean, in the second page, second last, you can see that REG field for AX is 000. Yeah, so is that okay? You can follow it? 000 for AX. You got it? Yes. So then what is the machine code now? So it's 00. So it becomes like, if I can write it here, it becomes like 0000 4 byte. Sorry, 4 bit. 0011, then 0000, and then 0100. So it is in binary, or we can write it in hexa like 0 P 04 H. Is that okay? So that means the machine code for this instruction, add AX comma square bracket SI, the machine code is 0304H. Is that clear? Okay, so let me now I can tell you how can how do we get for mode 00, register oblique memory is 100. I say that AX is for register. Okay, here AX is for register because this one is for memory, so definitely we don't have choice to I mean to take another option. So AX is for REG. So this REG field is for AX. And what about the register oblique memory? It is related to the mode. And here it is for mode 00. So if I go back to the table here, now I can. Yeah, guys, you can hear me now? Is it okay now? Yeah, but I think the system is showing a lot of problem. It becomes freeze or like it stops operating. So I don't know where is the problem. I mean, for last few days actually this problem actually we are facing. Anyway, so is it the problem of Blackboard or internet problem? I'm not sure. So have a look this table. Okay, so you can see that mode 00, this is for the memory mode without displacement or no displacement follows. So here, so look at here. Now for mode 00, we can see that we have 8 options. Okay, so one of the option is that the memory, so definitely memory is represented by SI only. So it is 100. Now is it clear? This 100 we use it in our machine code. Is it okay now? Yes. Okay. So and then for resistor field, REZ, for resistor field it is for AX. Okay. And we can use the table for resistor, or we can use it from here also. It is the same. You can see for AX it is 000. Or if you look at the another table. Okay. Let me, yeah, this table for REG field. Yeah, so you can see that for AX it is 000. So that means we use that this information. All right, so hopefully it is clear now. So that means what is the machine code for at AX comma square bracket SI? The machine code is 03 and 0304. So 2 byte. Okay, 0304 0304H. So it is how many memory location it needs? How many memory location to save this one on the memory? How many memory location does it need? 2, because it's 2 byte. Yeah, not 16 memory location, it's 16 bit or 2 byte. Okay, so that means 2 memory. So this one in one memory location 03 will be saved, and another memory location for 04, because this one is in hexadecimal. So 2 bit is 1 byte, this 2 bit is 1 byte. So in memory actually it's in a binary format, but we, for our simplicity, we write in a hexadecimal format. All right, so this one, right, 0304H, this is actually we already discussed. Okay, now it's about like we have a instruction. Okay, move AX comma to 200H, move DS comma AX. So this is the initializing, that initializing the data segment. Then move SI comma 100. Move SI comma 100 to initialize the source index register. Move DI comma 120 120H. So it is initialize the destination index register, and initialize the counter with 10H. So 10H means what will be the counter value in decimal? It's 32, right? 32. So yeah, 32 or 6, yeah, 4 to the 4 32, yeah. No, 2 to the 4 4 16, sorry, 16. So 16 counter value is loaded with 16 decimal or 10s. Okay, it doesn't matter. And then move AH comma square bracket SI, move square bracket DI comma AH. That means, okay, so what kind of so this one is actually yeah, moving a string data from one memory location to another memory location, right? Can you remember this thing? If for example we have we have a set of data. This one actually we use it many times, in the lab, and also a control flow instruction. In that chapter we use it for different application. Can you remember that one? Yeah. So like we have a set of data. They are in old location. Now we'll move them to new location, something like that. So this one is the offset address is ds colon 100, and here for example ds colon 120. Okay, so for example we have few data. They are here. They are here. Yeah, like few data, 16 data, for example. We have 16 data with the offset address 100h. So now we'll move them to new location with the offset address 12h. So what actually we do? We, for example, so source index, we initialize the source index register with 100 and destination index register 120, right? And then we take one by one. We take this one first. How actually we take it? Move AH comma or any register AL comma or any register you can use. Move AH comma square bracket SI, and then move a square bracket DI comma AH. That means first data, the first one we copied it here. Then we will go to the second one. Okay, because how actually we go it? We increment the SI, and then also decrement the increment the DI also, and counter value will be decrement CX. And then if it is not 0, then we will repeat this thing again here. Okay, so how many times it will repeat? With the counter value. So counter value 16, so 16. Yeah. And then this next line is NOP. NOP means no operation. No operation, or for example it is end, and this is the end of our program or something else. Here it is given NOP, no operation. It will do nothing actually, like that. So program is easy, right? Program you already know it, but now we'll see. What will be the machine code for this whole program? Okay, so you have a question here in this program, because this one is we discussed many times. Like control flow instruction, that chapter we use this one many times, and it's also in the lab. Also, I mean, it's not a new thing. All right. Any question do you have here? Yeah. Okay, so then now we'll see one by one what will be the machine code for this one. Okay, so now look at here. Okay, so first instruction is move AH comma square bracket, move AH comma to 2000H 200H. Okay, now open the table, open the new file that I share with you. Okay, all right. I think probably I will also have open it here. If you can open that one, you can see in the first case we have some different types of move operation actually. If you look at here, move is not one type of move operation. We have many types of move operation. So one is like register or memory to or from register. So that means register or memory to or from register, immediate to register or memory, immediate to register, memory to accumulator, accumulator to memory, register or memory to segment register, or segment register to register or memory. Okay, so all the move operation within this one of this format it follows. Okay, now look at here. what is the move operation here? Move AX comma 200H. That means immediate to the register, right? Immediate to register, because that one of the, if you can remember the addressing mode. So if one of the operand is data itself, then we call it a immediate addressing mode. So it means which format it follows? Immediate to register. Is that okay? Do you understand this one? Is it okay? Immediate to register. Okay, so now it said, so what is the format for this one? 1011, then W, then REG. Okay, so what is the W now? Is it a 8-bit operation or 16-bit operation? This is a AX because the yeah 16-bit operation. So W will be 1. Okay, so definitely W will be 1. And what is the REG field? REG is for AX, right? So AX is so we already know it, that REG field for AX is 000. So look at here, first byte is done. So first byte is 1011, and then here it is 1, W is 1, then 1000. So that means it is 1011. It is B, right? And B8, it is first byte. What about the second byte, or if we need the third byte? So third byte, it is the data itself. So what is the data? It's the data is 200H, right? So move AX comma 200H. This is our data. So data is this one. So that means what is the byte? This is the first byte and this is the second byte. So that means we need two byte. So what will happen? So last byte will come first. Lower byte will come first, because lower byte will save in a lower memory location and higher byte would save in a higher memory location. So that means 00H it will be in the second byte, and 20H it will be in the third byte. Is that okay? I said you know, can you remember when we discussed in the microprocessor architecture? So we in the lower byte or in lower memory location, higher byte in higher memory location. So we start from lower memory location to higher memory location in a memory segment, you know. So that means, yeah, so that means, you know, yes, in a binary format it's like that. Yeah, binary format it is like that, because 2010 is like that. Yeah, so but in a hexadecimal we write it 00H. That's why I write it 00H here, and then third byte is 20H. Is that okay? So that's why you can see that, and so this is the format. So 1011, and then W is 1, and REG for AX is 000. So it is like that, 10111, and then 000. So this is the first byte, and the second byte. So second byte is 2000H. So lower byte will come first. Lower byte is is 00H, or we can write it 40 and 40. Okay, so this is the second byte done, and then third byte will be 20. So 2 is 0010, and then 0000. All right, or we can write it in hexadecimal B80020. So this is our machine code. No. So in example one, example one was move AL comma BL, but that one is for register to register. We'll see it, but this one is immediate to the register. Okay, so a different example. It one is not different. It is totally different one. That's why we use, so our table we follow, yeah, I mean we do it by dividing 6 boxes. No, it actually yeah, so if you can remember, okay, look at here. For register to register, this one will format this one. You can see register to register or memory to or from register. It was in that format. So it was in like that. Move. I mean, this is for the opcode. This one is for the opcode, and this one is for D and W. This is the first byte, and then MOD, REG, register oblique memory. Okay, so if we need this, we can use that one if there is a memory. Otherwise, we don't need. So this one actually we use it. Okay. Okay. So, but now actually that was one example. But now we may have different types of move operation. So we will follow this table. I mean, we'll follow this one. Different types of move operation. So for this case, our move operation is immediate to register. And for immediate to register, we use this format. Okay, this format. So first byte is done. This is for the first byte, and second byte is data. And data, if it is 8-bit data, so we write we need 1 byte. But if it is a 16-bit data, we need 2 byte. All right, 2 byte. So if it is a 16 byte, lower byte will come first and then higher byte. So is that okay? You can see. So this is it is this one now. So first byte is B8 and second byte is second byte will be the lowest byte of the data, and third byte will be the yeah, highest byte of the MSB byte of the data. Is it okay? Clear to you? Okay, so any question do you have? Is it clear? Yeah. Okay. Okay. Now, what is the second line? Yes. Okay. All right. Second line was move ds comma ax. So second line was move ds comma ax. So here register to segment register. Yes, you are right. So register to segment register. So what is the register to segment register? Register or memory to segment register. That means it is 1000 1110. So first byte is actually it is already given. First byte is here, and then second byte is MOD, then 0, then segment register, then register or memory. And rest of the thing is it depends on memory. If it is memory, but here we don't have memory. It is registered to segment register, not memory to, yeah. So it is a so now for the mode, it is a register mode definitely. And register mode, we know it, for register mode it is 1-1, right? Register mode it is 1-1. All right, register mode it is 1-1, and then this 0 is given. This 0 is this byte is, and now it's about this. Okay, first of all, segment register as now segment register, and then it is register oblique memory. Okay, so mod is related to the register oblique memory. So let us have a look. Okay, so here actually I think it's not register oblique memory. It is about the REG actually. So we call it a REG. REG. It's I think actually this one we should fix it, because here what was the instruction? Move ds comma ax, right? Move dx comma ax. So that means register to memory, so register to segment register, sorry, register to segment register. So segment register is ds, we do understand this one, segment register. What about this one, register or memory? It is also same, we can say it is the REG field. Okay, register or memory or REG field. Okay, it doesn't matter, whatever it is. So it is for AX. Okay, AX. If you look back in the in your file, or I will open the table. Let me open the table here. Yeah, if you look at here for mode 1, AX is the REG field or okay, so AX, for AX it is 000. Or if you come back here, if it is we declare it as an REG, this is also 000 for AX. You can see for AX it is 000. Okay, doesn't matter. So yeah, so this one is 000. We got it. This one is 000. We got it, and mode is 11. We got it, and then here 0 is default. And what about the segment register? So segment register, if you can open the file that I share with you. If you open that one, you can see on the fourth page. Yeah, you can see that there is a table for 2-bit segment register 2-bit. For data segment DS it is 11. You got it? This one is segment register. For data segment it is 11. Data segment register DS it is 11. It's okay? You got it? Is it okay? So can you hear me? Yeah. So for data segment it is 11. Is that clear? All right, so that means it is done. So that means what it is now, it is 100, this is 8, and then 1110, it is E, 8E, then 1101, it is 9, no, not sorry, 1101, it is D, right? It is D, D, yes. It is D, and then 1000, it is 8. So that means our in a hexadecimal we can write it 8E, 8E, and then D8 in hexadecimal. So the machine code for this instruction move ds comma ax is 8e d8. So this is actually this one. Look, yeah, here is a mistake. I think it is 8. So it is not b actually. Actually, it looks like this one is 8. You can correct it. 8e 8e d b. No, it is also 8 actually. I think probably it looks like 80 dB. So 8 8, not B, not B. So is that clear? This one, move ds comma n square bracket si. Okay, all right. Yes, all right. Now let us go to the next instruction. So look at here. Now in the memory, look at here. So in the memory, for the first one, first one move ax comma 200h. What was the machine code? Machine code was B80020, right? If you can, if I'm not wrong, yeah, this one was the machine code B80020. So that means B8, it will say first in the first for example, the initial first memory location is 200. Then second one will be 00, and then the third byte is 20. So that means 3 memory location it needs for the first instruction. Then for yeah, then what was the instruction for the second instruction? Move ds comma s. It needs two memory location, two, because it's 2 byte. So it is I mean 8ed8, two memory location. So that means for these two instruction, we already occupied 5 memory location. Is it okay? Is it okay? For if a first memory location is 200H, then it one will be 201, 202, 203, 204, so on. So that means we are in this line. This until here it is done. Is it okay? Okay. Then what is the next line? Next line in our program. Yeah. Next line is what is the next line in our program? Yeah, next line in our program is move si comma 100h, 100h. So this is the same as like that. It is immediate to register. Okay, so it will follow the same format. Move si comma 100h. Okay, so let us have a look. Move si comma. So what is the move si comma 100h? So what is the format here? Immediate to register, right? Immediate to register. So because as it is immediate to register, we don't have to, we can also use this one, immediate to register on memory, but it is clear, very much clear, immediate to register, we use this one. Okay, so 1011 and W is also, W is 1. Okay, let me write it here. Move SI comma 100H. Okay, so yeah, can we use immediate to register memory? We can use it, but this is already very much clear. Immediate to register. I think we should not go for that option. Okay, so yeah, both format maybe that one will work also, even though they are not same. But because we will use, I mean, we can use this one because it is very clear. Move si comma 100h. So in this format, you can see, look at here, is it a 16-bit operation or 8-bit operation? The register is 16-bit. Okay, if your register is 16-bit, even though data is not in 16-bit format, but we can add a 0 here in front of to make it a 16-bit. So it is first byte and second byte. All right, so definitely it is a 16-bit operation. So W is 1. So W is 1 here. And what about the REZ field? Now what is the REZ for SI? Yeah, look at here, look at the table, REZ field for SI. If you, I mean, page number 4, for SI it is 1110, right? Yes, very good, 110. So 110. So that means what is the first byte now? It is complete. First byte is 1011. So that means it is B, right? B. B. Okay, and then 1110. So it is E. All right, and then it is about the data. So data is again here, as it is a 16-bit operation, so data is also 16-bit format, even though data is 100H given, but in a 16-bit format it is 0100. So first of all, yeah, so so that means second byte will be 00H. It will be, yes, you are right, and the third byte will be 01H. 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 That means it will be 00 and then 01H. All right. So that means it becomes like BE00, BE00 and 01. So 3 memory location it needs. Is it clear? Is it okay? Yes. All right. So that means let us have a look in the memory. Look at here. Move si comma 100h. So it needs 3 memory location. So be 0001. So next 3 memory location it occupied. Next 3 memory location it occupied. So now what will be the machine code for move di comma. So what is the next instruction? Move di comma 1 to 120h. Okay, look at here. So here this is also same as immediate to register, only the change is in di. But and in a 16-bit format, so because it is a 16-bit operation, di register is 16-bit. So definitely this one is in also 16-bit format we have to write. So we can add a 0 on the left. So 0 1 0 2 0, right? So data is 0 1 2 0. All right, 0120. So now again, so which format we will use? This one, immediate to register. 1011, this is fixed, and then W is 1. And what about the register for DI? What is the value of register for DI? 111, right? So it becomes 111. 111. Okay, now it's about data is very easy, because what is the lowest byte is 20, right? So 20 H. Actually I put the H here because actually it's written in a hexadecimal format. 20H and then 01H. 01H. Okay, so that means what is the machine code now? Complete code is 1011. It is B. Okay, and then 1111 it is F, and then 20 and then 01 in a hexadecimal format. Is it okay? Yeah. Other guys, it's okay? Okay, so that means it is clear now. Hopefully you got it. So that means here also it needs 3 byte or 3 memory location, BF2001. So next 3 memory location will be occupied here for this instruction. So look at here, move di comma 120h. So that means BF and then 20, then 01h. So next 3 memory location it occupied. 3 memory location it occupied. All right. So then what will be the move cx comma 10h? Look at here. It is also same format, right? Move cx comma 10h. Okay. So what is the machine code for this one? So look at here, as it is a register is CX is 16-bit, definitely the data it also in a 16-bit format. So 0010h, right? In a 16-bit format, this one 0010h. All right. If we put 0 on the left, it doesn't change the value, right? Is it okay? Do you get it? It's okay. All right. So then what will be the yeah, so again it is immediate to register. Again it is immediate to register. So 10010. So and then what will be the W is 1 here. W is 1 here, and RSG for CX. Yeah, RZ for CX is okay. Let me also verify. CX is, yes, you are right. You are right. So that means 0, 0, 1. So that means first byte becomes 1011. It is B, okay, and then 1001. It is 9, B9, first byte. Okay, and then the second byte will be data, third byte also data if it needs. So here as it is, look at here. So what is the lower byte? Lower byte is 10. So that means 10 will come first, and then what is the higher byte is 00. So this is the hexadecimal format in a, so B9 1000. Is it okay? Clear? So if you look at here, so for this instruction, it is B9 10 and then 00. So this 3 memory location it needs, next 3 memory location. All right, so that means immediate to register we got 4 example. Very good, so they are similar. Now we'll see what is the next instruction. Move AH comma, this is the next name, AH comma square bracket SI. Okay, if you, okay, let us go to the main program. Okay, here until here we done, until here it is done. Okay, so now it is within a loop, within a loop. Move AH comma square bracket SI. Move AH comma square, so that means it is memory related. Yeah, memory to register. Yes, memory to register, definitely. Let us have a look which format we can use. So memory, yeah, so memory to register. So in the first line, right, first one is okay. Memory to register, or oblique memory to or from register, we can say memory to register. Okay, so memory to register, it's okay. All of you get it? It one, this, which format is this one? Move AH comma. So what is the what type of format this one? All of you clear? This one is the first format, right? Register, memory to register. It is like register or memory to or from register. So we can say it is register, memory to register. All of you clear this one? Guys, can you hear me? Yeah, so I want the response from other guys. So yes, okay. If it is clear, then okay, let us follow it. So it is the, what is the first byte is, now look at here, 100010, and then D. D is direction. So D for direction, right? If it is to register, then it is 1. It is from register, then it is 0. So look at here, our register field is AH, right? Register field is AH. So it is a 2 register, as it is a first operand, so 2 register. So that means D is 1. Okay, very good. D is 1 here. And what about the W? W is it a I mean 8-bit operation or 16-bit operation? Yeah, because look at here, our register is 8-bit, so definitely register it will take one memory location data. So it definitely W is 0. W is 0. So that means first byte is complete. What would be the first byte now? First byte is 1000 is 8, and then 1010. So it is A. 1010 is A. Okay, this is the first byte is done. Then it is about the mode. Look at here. So as it is a register, so it is a it involves the memory. So that means memory mode, but without displacement. So that means no displacement follows. So that means what is the mode now? Mode will be 00, right? Mode will be 00. All right, and then yeah, and we say that so register of memory is related to the mode, and RSA field is fixed for AH. So okay, so what is the what will be the RSA field? Okay, we can take the RSA field. RSA field. Let us open that one. RSA field for AH. If you look at here, RSA field for AH. RSA field for AH is 100. 100. 100. Is that clear? RSA field for AH is 100. Abdul Hadi, you said it is 10. Yeah, you are right. But what about the other guys? Is it clear? For RG field, the AH is 100. Yeah, okay, fine. And then what about the register of memory? Look at it is related to the mode. I always said the register of memory is related to the mode. We will see the mode, the table. Okay, let me check it. Let me check it, and then yeah, this one is already also we use it for SI. It is 100. Yeah, 100. Okay, so if you need, I will open it again. I will open it because let me finish it if you have it not clear. Already we use this one in one of the example. Okay, let me finish it. So it becomes like 00100100. So in a for nibble, as a nibble, it is first nibble, yeah, it becomes like 0010. So 0010 is 2, and then 0100. So it is 4 to 4H. Is it clear? 8A to 4H. All of you clear? Yeah, so other guys, is it okay? Okay, let me yeah, okay, then it is fine. It's fine. So I will open the yeah, how actually this mod related to the register of memory, it is 100. Okay, I will verify. So 8A24 machine code is 8A24. Look at here. For this instruction, we need two memory location, 8A, 8A and 24. Okay, so next to memory location is occupied for this machine code of this instruction, 8A24. All right, so let me open that one, what I said. Yeah, if you look at here for yeah, memory mode, no displacement follows. It is 00 mode, and for 00 mode, if you look at here for 00 mode, what will be the register or memory? So if you look at here, the memory is represented by the SI. So for SI it is 100. Okay, and in a register field, for AH we put 100. That's it. Okay, now let us go for the next instruction. What is the next instruction? Move square bracket di comma ah. move square bracket di comma ah. So let me write it, move square bracket di comma ah. What is the machine code for this one? So now look at here. So which format it is? The first format again. Yeah, memory to memory to register. So in the first format, we can see that not memory to register, register to memory. So register to or from so it is same or other way actually. Register or memory to or from register or to or okay, or you can say that from register to memory. From register to memory, we can say, right? From register to memory, because yeah, register or memory to register, or from or from register to memory or register, or we can say from register to memory. Okay, is it okay, right? Is that clear which format it is? Yeah, so register to memory. So memory, because square bracket is memory, and memory is not directly given here, memory location. So it is represented by di. Okay, so now it follows like 100, 1000, then 10. It is given already, and it is d. So it is from register or to register. Yeah, so it is d is 0 from register, so d 0. And whatever w is, it is 8-bit operation, because register is 8-bit, so it is also 0. So that means it becomes 1,000, it becomes a, and then again 1,000, it becomes 8. So 8 8 8 8. Okay, first byte is 8 8. What about the second byte, MOD? So it is a register mode, right? So we can say it is a 00 with a register mode without displacement, or with no displacement follows. And then REG for AH. REG for AH is what? What is what you say? Is 100, right? Okay. Okay, now look at the chart. Look at the chart for MOD 00. What will be the register oblique memory for DI? Tell me. All of you agree? 101? All of you can get it? 101? You can check on the table that for mode 00, the register oblique memory code for square bracket DI, or for DI, I mean the memory represented by DI only, it is 101. Is that okay? All of you get it? So then it will be 0010. 0010 is 2, and then 0101, it is 5. So it becomes like 8825H. So that means next to memory location will be, yeah, for move AH comma square bracket 8A. It is not B actually. 8A 24H, but we say 25H. Where is the mistake? Let me check. Oh yeah, next to, sorry, this is our, yeah, this one, this two, right? Yeah, 8B25H. Yeah. Yeah, these two line. Actually, I'm checking that the previous one, not this one. Yeah, 8825H. We are right. 8825H. Yeah. So this is okay, right? Until now, okay. Yeah. So then, what is the format for increment? Increment SI. Our next instruction is increment INC. Increment SI. Increment SI. So look at here, increment for increment format, we have increment for if it is a register or memory, we have one format, or if it is just directly register, we can write in this format. So this is easy for us. So 0 1 then 000 then register. So here the register is SI, right? What is the register for SI? What is the RSI for SI? Is 110. It's 110. So that means we can just write it 110. Then it is done. So that means it just need 1 byte only. So like 0100, it is 4. Now first option actually it is not, I mean second option is easy for us. So don't go for the first option. I think it may work definitely, but I am not, I mean second option is good for us. So 0100, it is 4, and then 0110. So it is 6, 46H. Okay, 46H. Is it clear? Increment SI 46H, only 1 byte, just 1 byte. Yeah, and then what is the next instruction? Increment DI. So just only in this what will be the hex code for this one? Yeah, DI. So the RSA field for DI is 111. Okay, 111. So it becomes like 47. It becomes 47H. Okay, and then our next instruction is decrement. Decrement CX. Okay, so decrement CX, what will be the for this one? So look at here, we will use the decrement option, decrement, and also the second option, the resistor. Okay, so 0100 and then 1 and then REZ. What is the REZ field for CX? REZ field for CX is 001. Yes, so that means it will be 0. RSG field is 001. So it becomes like 0100 is 4, and it becomes like 4, and then 1001. So 1001 is 9, right? 49H. So that means for increment SI, it is just only 1 byte, 46H. Then increment DI, it is 47H. Then decrement CX, it is also 1 byte, 49H. Are they clear? Clear? Okay, so yes. Okay, let me now have a look in the memory. Yeah. So for increment SI, it is 46H. Then increment DI, it is 47H. Then decrement CX, it is 49H. Everything is very clear. Now only the challenging thing is this jump instruction. Next line is our, look at here, all the things done. All the things done, or until here, we finish. Until here we finish. But next line is jump. This is the tricky part. Jump not 0. So if Cx value is not 0, then it will do a jump. It will, that means it is a loop operation. Okay, it will do a jump in this line. Okay, now what is the format for jump? It is a conditional jump, right? It is not an unconditional jump. Jump not 0. If it is not 0, then, or if it is 0 flag is not 1, if 0 flag is not 1, then it will make the jump. Main thing is like that, because not 0 means how actually it check that Cx is not 0. That means you always check the 0 flag. If 0 flag is not 0, 0 flag is not 1, then actually, because when the result is 0, then 0 flag will be 1. Okay, so so now have a look. What is the format for this jump instruction? Okay, so this is the unconditional jump. What is the conditional jump? Oh, the format is not given here. I think by mistake. Okay, it is not given here. But if you look at the file, I mean that I share you today. If you look at this file in the third page, if you look at here in the third page, you can see that there are many conditional jump instruction: jump 0, jump or jump equal, or jump 0, and jump not equal, jump not 0. If you can remember, you can see that jump on not equal or not 0. What is the machine code for this one? 0111 0101. So it is like, let me write it down. So jump not 0, for jump not 0, the format is 0 1 1 1 0 1 0 1. So first byte is clear, first byte is completely, and second byte is displacement. I mean, how much actually we have to do, how much memory location it needs jump. Okay, so that means it is 0 triple 1 and then 0 1 0 1. Yes, you are right, you are right. So now look at here. What will be the, how much it will be, how much it will be the displacement. How much it will be the displacement? Let me go. Yeah, look at here. Yeah, so 0 1 triple 1, then 0 1 0 1. This is our this first byte is it is given already. So second byte is for displacement. Second byte is for displacement. Okay, so second byte is displacement. Okay, how can we get this displacement? Yeah, okay, so now look at here. Let us go back here. So in this memory orientation, or you can just write the binary format here, like, you know, move ax comma to 00h. What is the machine code for this one? Is B80020. Okay, and then what is the move ds comma s? So machine code for this one is this one. And move si comma 100h. What is the machine code for this one? This one. Okay, or move di comma 120h. What is the machine code for this one? This one. Already, this all the things we already got it, and we can write it in a table like that, or as a memory file also. We can also write it any format, we can write it. Okay, for move di comma 20h, it will be this one. Okay, And then what about the increment? All this thing, this three things is here. Yeah, 46H, 47H, and 49H. Now jump instruction. Jump not 0, then it will come which level? NXT PT. So it is this one, right? This level. NXT PT is this line, right? It's represent that means the level is here. It will come this memory location, beginning of this memory location. Okay, so now, okay, so that means if you now come to the memory file, then it will be more easier. So jump not 0, it will come here. Which line? Here. So in this line. But from where? You know that what is the next line after this line? Next line is this one. Okay, and for this jump not 0, first byte is clear. First byte is okay, 75H, right? 0 111 0101. It is 75H. It is okay. But this one we are not sure. It is XX, for example. We are not sure. We will find it. And then what is the next line? Next line is NOP, or maybe it is end. Whatever it is, NOP for the machine code for NOP for a no operation, it is 90H. It is given. Okay. But for okay, for example, so what is the next line of jump not 0? Next line is NOP, right? So when actually microprocessor is executing a line, a instruction pointer actually holding the next instruction. Instruction pointer always indicating the next instruction address. So that means when the microprocessor is performing this instruction, jump not 0, this line, it actually, where is actually the location of the instruction pointer? Here. IP is actually in this, indicating this location. IP is here, instruction pointer, because code segment, in a code segment, IP works with a code segment instruction pointer. So that means from here to it needs a jump until this line. Okay, so from here to here it is, because jump not 0, it will come actually this line. But from where? IP needs to make a change from here to here. Is it okay? Do you understand this one? Yes, is it okay? I'm saying that when actually any line, so microprocessor, when my execution unit is performing execution of a line, instruction pointer actually holding the next instruction, holding the is actually indicating the next instruction. So next instruction is this one, IP, sorry, NOP. So IP is actually indicating the next instruction. That means when actually, I mean, it needs a jump from this line, it needs a jump here, actually here. So that means IP value, it needs a change from this location to this location. That means it's actually going back. It's actually going, you are going back. Instruction pointer is going back, not forward. It's the jump is backward jump. So how many memory location it needs back? It needs to go back. So let us calculate from here. Calculate from here. So if from here, you can see from here. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is the beginning of this line. So 9 memory location it needs a back. So that means we can say -9. This jump means actually instruction pointer needs a backward jump of 9 memory location. That's why -9 it is. Is it okay? Is it clear? All of you? Okay, this is I said again. I am saying yes. You okay? Good question. So I said that when actually microprocessor is executing a line, instruction pointer actually indicating the next line. Okay, so what is the next line? Next line is NOP. So that means your instruction pointer is actually this location. So your calculation should be start from this location. Okay, now Amod. So I mean, microprocessor, when actually microprocessor is executing a line, instruction pointer actually indicating the next line. Next line is NOP. So that's why we have to calculate it from NOP. So if you calculate it from NOP, then how many memory location you have to go back? Huh? Only one instruction will be counted after. No, it's not necessary that only one instruction is there. But right now, for example, only one instruction is here in these cases. So NOP is the instruction. So that means it actually indicates, so it needs calculation from this line to the, I mean, where actually it make a jump. So it make a jump here, right? The beginning of this line. So the beginning of this line, so that means how many memory location you go, it needs a back 9 memory location. So that's why -9. So displacement field actually will be for -9. Okay. So this one actually looking the memory, I mean memory profile, you can calculate it, or you can calculate it from here also. Look at here. So for example, NOP, the operation. So here, jump not 0, it will come here, this line, right? This line. So that means how many memory location? We are not sure. We know 75H. 75H. This is clear. It is given, but this field is not given. We have to find it. For example, this one is XX. What is the value of XX? We will find it. Okay. So when actually microprocessor is performing the execution of this line, instruction pointer is actually holding this line. So that means how many memory location it needs a back from here to here. How many memory location? So here 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So 9 memory location back it needs, it will do the jump. Okay, so that means displacement field is for 9, -9. So we know that what is the, so -9 negative. So what is +9 in 8-bit format? So 0 0 0 0 and then 0, sorry, 1 0 0 1. Yeah, 2's complement of this one, because it is 9, right? It is 9. 0 0 0 0, and so actually 9 we need say 4-bit, but it is in 8-bit format. Others are 0. On the left we put 4 zeros. So 0 0 0 0 1 0 0 1. This is 9 +9. So what will be the first complement? 1 1 1 1, then 0 1 1 1, and then 0, right? So this is the first complement. And then if you add 1, then it will be what? 1 1 1 1 0 1 1 1. Okay, so this is the -9 actually. So 2's complement of +9. It is the -9. So we can write it. This one is the F, and this one is 7. So that means F7. So that's why we write it here F7. F7 -9 means F7. So that means, and also here we can see that 75F7. Is it okay now? Clear for this jump, conditional jump? All right, and NOP is given for 90. So this is very simple instruction. NOP, no operation, it is given. But if it is like, for example, here we have an instruction, okay, in this program, main program. Let us go back to main program. This program, instead of NOP, if our instruction is END, this is the end of our program. And if it is like that, what is the machine code for end? Does it is okay? It is a judo instruction, so there is no machine code for this one. Clear? NOP is not a pseudo instruction. It is its instruction. Its machine code is given 90H. But if it is an end, just we write end, and so that means it doesn't has any machine code. It is the same. It is the same. It is the same. -9, yes, it will be the, even if it is n, because when actually microprocessor is performing this instruction, it actually indicating the next memory location. It may have instruction, it may not have instruction. It may have I mean real instruction, it may have a zero instruction. Doesn't matter. It indicating the next line. That's the main thing. Okay. So now it's about the quiz. So when will be the quiz? So you want a quiz for machine code or the previous chapter? Control flow instruction. I think previous chapter or control flow. Which one actually you want? Control flow. Okay, because I need two quiz before the measure 2. So before the measure 2, one will be on machine code and one will be the control flow. So control flow instruction. So when will be the quiz? Next Wednesday, next Tuesday, okay? Next Tuesday. All right, so next Tuesday I'll announce it on the blackboard also. So it's based on the control flow instruction. Okay. So, and because I need another quiz before the measure 2 on this chapter, so that you will be prepared enough for measure 2. So yeah, okay. And I'll see about the homework. Is there any homework we need it or not? I will check it also. Okay, so do you have any question so far? I hope it is clear, right? Tomorrow lab, yes, inshallah. Tomorrow will be a lab. So come to the lab as according to the time slot. Because group 1 will come at 2 o'clock. Group 2 for this chapter template. Yeah, it is already I uploaded on the blackboard. The template for this chapter is uploaded. Yeah, I uploaded on the blackboard. Machine code template. You can see there is a file machine code template on the blackboard. I uploaded yesterday. So yeah, it is available on the blackboard. So tomorrow lab, you will follow the your group time. Group 1 will come at 2 o'clock, and then group 2 3:30, and group 4 and so on. Okay. So this will follow your timetable, and yeah. All right. So I hope this is where is the. Okay. So you know your time, right? Let me. Okay. Yeah. So group 1 at 2 o'clock, so 2 p.m. and group 2 at 3:15 and group 3 at 4:45. Okay. So it is, you already know it, or you can check it on the blackboard that actually I have uploaded. So yeah, so come on time, okay, inshallah. So see you on the lab. Okay, so any question do you have today? Okay. Okay, so thank you, see you inshallah tomorrow.